is 0.2423 times this isotope's mass, which is 37, and that's it. So let's go ahead and do the math here. I found out that this was 26.52 plus this right here came out to 8.97 equals 35.49 AMU is the correct SI unit, atomic mass unit. Okay, let's go ahead and keep practicing and turn the page to the next one. Another practice problem over here. Let's read this one, example 2. There are 2 isotopes of copper. Copper 63 has an abundance of 61.1%. Copper 65 has an abundance of 30.9%. So isotope 1, isotope 2. Calculate copper's average atomic mass. Okay, let's go ahead and do that. First step is take this out of a percentage and put it into a decimal by moving the decimal place over. 1, 2. Move this decimal place over. 1, 2. There we go. So 0.691, multiply it by the mass number, which is 63, plus 0.309 multiplied by the mass number of 65. Let's go ahead and do this math. If you're going to plug it into the calculator in one shot because you feel like it's faster that way, which I understand, please make sure that you put parentheses around it, because you need to follow the PEMDAS, please excuse my dear Aunt Sally, and the parentheses need to be done first before you add those numbers together. Okay, so this comes out to 43.53 plus 20.09 equals 63.62 AMU. Okay. So hopefully not a bad, hopefully not a problem. Hopefully you're able to get through this okay. This formula is on the formula chart. Okay? So you don't have to memorize it. Let's keep going. Now we're getting to the good stuff. The chemistry stuff. The really good chemistry stuff. Let me go ahead and give you a heads up. This is going to use the dimensional analysis math that we've already learned in last unit. Okay, last unit was helping guide us to this. What we learned here, we're going to use it throughout the school year. We may not use it in every single unit that we talk about, but believe me, second semester we're going to go through this and need to know how to do moles. Okay, so let's make sure that we know what we did last unit and we can't forget it because we still have to use that here. So let's go ahead and continue. Chemists count by what we call moles. Okay, what is a mole? Now the abbreviation or shortcut for a mole is a MOL, mole. So they just take away the E, that's it. Now we're talking about a mole in chemistry, not a mole as in the animal that lives underground. Okay, so first thing here, which is so super important, what we need to know about the word mole in chemistry class. Well, and we're going to have to practice it so we can get better. Avogadro's number. So when we talk about a mole, you need to know Avogadro's number. And this is a number that you really do need to memorize. 6, which equals 6.02 times 10 to the 23rd power. That's a big number. And that's a positive exponent. So yes, that is a big number. It's not a negative one. Okay? That's a huge giant number. And this number, Avogadro's number, equals 1 mole. 1 mole of the element, 1 mole of a compound, 1 mole of what we call a formula unit. we're going to get into moles, and we consider everything in moles. Okay, so you saw the video notes already, and they talked about this. Kind of like when people are chefs, and chefs, when they're talking about cooking or they need a certain amount, let's just say eggs for an example. Do they order eggs like, okay, I'm going to order eggs and I want 62 eggs? Or let me go ahead and get 24 eggs because I'm going to be doing a lot of cooking. No, they don't buy eggs by the single individual, okay? Because when they need to cook a cake or something, they probably need 3. And if they're cooking 12 cakes, then they're going to need, 3 times 12. And eggs, when you go to the grocery store, most of them, some of them now come in these big boxes or weird, containers, but most eggs come in a dozen. So if there's a chef who's about to make a whole bunch of cakes and brownies or something, and they go and figure out how much they're going to make, then they can say, okay, I'm going to need 2 dozen eggs. They don't say I need 24 eggs. Same thing in chemistry. So in chemistry, when we're talking about it, whether it's a compound, a single element, or what we call a formula unit, we don't say, oh, okay, I need to make this chemical reaction work, I need 72.84 times 10 to the 67th atoms of this. No, that's not how they call it. They say, I need 3 moles of it. Okay? 3 moles of it. I need 2 moles of it. And that's how they are going to look at things when it's a compound, whether it's a reaction, whether it's just atoms by itself. Okay? So let's continue. So when it comes to the word mole, a mole is really an SI unit. So an SI unit for distance is going to be a meter. An SI unit in science class for liquid is going to be a liter. Okay? An SI unit in science class for the amount of substance is a mole. Remember, that chef is not going to say, oh, I need 17 eggs, or oh, I need 24 eggs. Okay? That chef is going to say, I need 2 dozen eggs. I need 3 dozen eggs. That is the amount of substance, the amount of eggs. And they don't say by individual because it's a little easier just to group them all together. Right? And sometimes they might, need a few extra ones. So let me go ahead and make it 3 dozen of eggs is what I'm going to order, or I'm going to go and buy. Okay, not a problem. Well, if you're going to be having a chemical reaction occur and you need a certain element, chemical or something, you're going to go and get it. How much are you going to get? Well, you don't want to get too much. Why don't you want to get too much? Because once you take it out of the container, you do not put that substance back into the container. That is called cross-contamination. What if somehow something in the air fell into that chemical, and now you put the whole chemical back into the container and all of it's ruined? Because of that, in chemistry class, when we are doing chemical reactions, we do not just pour, and so here we go. I'm going to go and pour me a whole bunch and then start making it. No, you go and get exactly how much you need. How much do you need? You better figure out how many moles you need of it. And that's how much you get. 1 mole of it, 4 moles of it, 4.75 moles of it. Okay? The next part here says the mole is used to count atoms or molecules or what we call salts. Which are tiny, right? So you need a lot before They're visible. All right? Atoms are so tiny. I need many moles of them before I can actually see it with my own eyes. So let's talk about this word over here, representation particles. We are going to use the words here. We're going to either talk about atoms, molecules, or what we call formula units. Atom. Well, I'm sure we all know what an atom is. An atom is going to be an element that is not bonded to anything. Right? It's just a single atom. If I'm talking about oxygen atoms, I'm talking about just pure oxygen atoms. They're not bonded to anything. They are just there floating around by themselves. Okay? Now, when we use the word molecules in chemistry class, we're talking about compounds. But we're talking about particular compounds. We're talking about compounds that are made of only non-metals. That's it. So let's look at a couple of examples here. Carbon dioxide, H2O, water, O2. Okay? Those are all elements that are on the periodic table, but they are bonded. This one has two oxygens that are bonded together. This one is two hydrogens and an oxygen that are bonded together. And then this is two oxygens and a carbon that are bonded together. Now, when you look at your periodic table and you see the stair step, on this side of the stair step are going to be our nonmetals. On this side of the stair step are going to be our metals. And no, we haven't had our unit over the periodic table yet. So those are our metals. Those are our nonmetals. And those that are actually touching the stairs, okay, are called our metalloids, meaning that they actually have properties of both a metal and a non-metal. It's like they're like the fence sitters. They can't decide if they want to go on this side or that side, so they act like both of them. Alrighty, so let's keep going. The next one is what we call a formula unit. So when we use the word formula unit here in chemistry class, we're talking about, we use the word salts. Yeah, kind of like table salt. Okay? There's a whole bunch of different salts out there. It's not just table salt that's the only salt out there. Now, formula units are compounds too, made of a metal and a non-metal that are bonded together. Okay, so for an example, NaCl, sodium chloride, is table salt that you eat. Okay, and the sodium is the metal part and the chlorine is the non-metal part. Okay, so let's keep going so we can finish the notes here. We've got moles that we're going to finish, and we're going to look at how to mathematically do them. Okay, let's look on, we're looking at the math part now is what we're getting to. So mass and moles. So let's go ahead and look at, let's pretend that this is going to be a carbon from the periodic table, and this is that little square on the periodic table. The top number is going to be the atomic number, the bottom number is going to be the mass number. Okay, so here it is. Now, as a quick reference here, just to like refresh what we talked about, the atomic number is the proton number and electron number. It's the same, right? Because they're considered to be electrically neutral. The mass number, yes, is the mass of, is the protons, this is an and sign, plus neutrons. But more importantly, it's what we call the molar mass. Yes, it is the atomic mass. Yes, that mass number is a decimal because it is the average of the isotopes. Yes, the mass number is the number of protons added plus the number of neutrons. But all of that, overall, this mass number is what we call the molar mass.